In this video, we'll be graphing some quadric surfaces using traces. A trace is a curve of intersection of a surface and a plane that is parallel to one of the coordinate planes. Let's begin with this quadric surface here. We'll start with the trace in the xy plane. To find the xy trace, we let z equal 0. When we simplify the resulting equation, we get this. You'll recognize this as a parabola in the xy plane. Next, let's look at the trace in the yz plane. To find this curve, we're going to let x equal 0 and solve the resulting equation to get this parabola. Now let's look at the xz trace. To find that, we'll let y equal 0. When we simplify the resulting equation, we get this, which you recognize as the equation of an ellipse. Now we're going to ask ourselves, what happens if we let y equal some constant k? If we substitute k in for y in the original equation and simplify, we end up with something that looks like this. And the idea here is that as k increases, we get these planes that slice our surface moving in the positive y direction. These will generate a family of ellipses all on the surface that we want. So our surface is looking something like this. This surface is called a paraboloid. Here's the paraboloid from several different perspectives, looking down at the xy plane, looking towards the xz plane, and looking towards the yz plane. Now try sketching the surface on your own. Start off with traces in the coordinate planes and with traces in planes parallel to the xz plane. If your surface doesn't look quite right at first, keep at it. These do get easier with effort and practice. Now let's take a look at this surface. Again, we're first going to look at the xy trace, meaning we're going to let z equal 0. When we simplify the resulting equation, we get this, which we recognize as the equation of an ellipse. Now we'll look at the xz trace. We do this by letting y equal 0 in the original equation, and the equation becomes this, which we recognize as a hyperbola. Now we'll look at the yz trace. To do so, we'll let x equal 0, and the equation becomes this, which is also a hyperbola. Now what happens if we allow z to equal some constant k? If we replace z with k in the original equation, when we simplify, we've got something that looks like this. And we recognize this as a family of ellipses. As k increases, these ellipses creep up the surface, as shown. These curves together give us this surface, which is called a hyperboloid in one sheet. Here it is from several different perspectives. Just as before, try sketching this one on your own. This one tends to be easier if you first sketch the elliptical traces parallel to the XY plane. Again, if it doesn't look right at first, keep at it. Try again. These get better with practice. Now let's look at this surface. First we'll look at the trace in the xy plane, letting z equal 0. When we simplify the resulting equation, we get this, which we recognize as an ellipse. Now we'll go to the xz trace, the trace in the xz plane, letting y equal 0. We end up with this equation here, which is also an ellipse. Finally, let's look at the yz trace, letting x equal 0. When we simplify the resulting equation, we end up with this equation, which also is an ellipse. Now, just as before, we're going to let z equal some constant k. When we do this and simplify the resulting equation, we end up with an equation that looks like this. You'll notice this is a family of ellipses as k increases from -4 to 4. All of these ellipses are on our surface, generating a surface that looks like this. This is called an ellipsoid. Now go ahead and sketch this one as well. Start off by graphing the ellipses in each of the coordinate planes. As was mentioned before, these get better with practice. So go ahead and sketch as many of these as you can.